Hey kids, Miss Kulkarni here. In this video, let's talk about measurements in chemistry. And when we talk about measurements, we always deal with accuracy. And how do we measure accuracy? Using percent error. So let's learn more things about both accuracy and percent error. But before that, let's find out we have data collection, and the data collection could be two different types. One is numerical and other could be non-numerical. And what's the one which we call? If it's numerical, we call that as quantitative. And obviously the one which is non-numerical, it talks about the color or the feel, so we call that as qualitative. So whenever there is a quantitative data, we use two things: accuracy or precision. Accuracy is simply the degree of closeness of the measurement to the actual value, or it is the true value. So the accepted value or actual value is the one which we compare with the value which we get in the experiment. Most often what we do is we use for accepted value a value which is in reference chart and it's already reported. So accuracy is many times we report as nothing but percent error. Let's find out some calculations. So here is the formula for percent error. Percent error is equal to, what do we have in numerator? Accepted value or true value minus experimental value divided by accepted value times 100. And I'm going to put it simply as A minus E divided by A, and that times 100. Alright, what is experimental value again? That is the measurement which you obtain in performing experiment in the lab. And what is the accepted value? It is the actual value which is reported in reference tables. Now keep in mind, percent error could be positive or it could be negative. That sign has some significance. If the value is positive, that means your experimental value is lower than the accepted value. And if it is a negative value, it means that your experimental value is much higher than the accepted value. Okay, let's do some real calculations now. So in this problem, we have some numbers given. Let's circle those numbers first. It talks about a student performing an experiment. He's weighing a beaker and recording the mass. The mass which student records is 47.21. So what is that? That will be experimental value, which is 47.21 grams. And then the actual mass, actual value for the mass is 47.93 grams. So how do you find percent error? Using the simple formula A minus E divided by A, that times 100. Let's just plug and check the values. So we get 47.93, which is the actual value here, minus 47.21, and that divided by 47.93, all of that times 100. And when we solve this, what is the answer which we get? We end up getting 1.5% as the percent error, and it's positive. Let's do one more problem. In this problem, the error is given to you and look at the value. It's positive 22.5. Make sure to use that value when we plug and check. And then they found the mass of object to be that. If they found That means that will be experimental value. So E is 122.4 and we already have percent error given as positive 22.5%. So when we plug the values, we get equation like this, equal to, we don't know actual value, so let's put A there, and that's your experimental value divided by A, and that times 100. Now this is little algebra there, so when you multiply both sides by A, we end up getting that as A, and when you multiply by 100, you end up getting 100 times A minus 12240. When we rearrange both these sides, we end up having 77.5 A equals 12240. And then when we solve that, the answer comes out to be 157.9 grams. So let's take one more problem, and you all are going to say, we already know the percent error. So in this lab experiment, where are the numbers? Right over here. And what does it say? In their lab results, student found out that value. Let's write down what is that? It is the experimental value, 20.7 liters per mole. The teacher informed that they had an error which is positive 7.59%, and we have to find, of course, what is the actual accepted or true value. So when we plug those, it's positive 7.59 equals A minus 20.7 divided by A times 100. We multiply both sides by A, we end up getting that times A, and then this will be A minus 20.7, that times 100. You multiply the other side by 100, and what do we get? 100A minus 2070, right? And then you of course bring A to one side, rearrange that, and what do we end up getting? 92.41A equals 2070. And then we divide both sides by 92.41, and we end up having A equals 22.4, and we go back with the same units which are given for the experimental value. So that will be liters per mole. So A is equal to 22.4 liters per mole. Look at that. How easy was that? So guys, I hope you learned how to find the percent error and how it is tied up with the accuracy of measurements. Well, I hope you enjoyed the video. I will see you in next video. Until then, bye bye.